Hi, I'm Bob. Welcome to the course that focuses on addressing the exercises at the end of each chapter in the textbook Microeconomics Theory and Applications with Calculus, the 5th edition by Professor Jeffrey Perloff. If you want to review the topics before trying to solve the questions, please check out the Introductory Microeconomics course. The link to the course is in the description below. We will answer the remaining questions for Chapter 6, Firms and Production. Let's go to exercise 6.1. Are the robots in the application robots in the food you eat an example of neutral, labor-saving or capital-saving innovation? Explain. It is a labor-saving technological innovation. These restaurants use robots to serve food, greet customers, and provide entertainment. They can replace waiters and waitresses. Let's try exercise 6.2. In a manufacturing plant, workers use a specialized machine to produce belts. A new labor-saving machine is invented. With the new machine, the firm can use fewer workers and still produce the same number of belts as it did using the old machine. In the long run, both labor and capital are variable. From what you know, what is the effect of this invention on the average product of labor, marginal product of labor, and returns to scale? If you require more information to answer this question, specify what else you need to know. We first look at the average product of labor and the marginal product of labor in the short run while holding capital constant. The firm can use fewer workers and still produce the same number of belts with the new machine. The average product of labor increases because of the technological process. So, the production process is in the range from point B to point C in the graph. In this range, as labor decreases, the average product of labor goes up, and the marginal product of labor also goes up as the number of workers drops. To determine the returns to scale in the long run, we need information about how much output increases if we increase both labor and capital in the same proportion. Let's solve exercise 6.3. Does it follow that because we observe that the average product of labor is higher for firm 1 than for firm 2, firm 1 is more productive in the sense that it can produce more output from a given amount of inputs? Why or why not? It is true that firm 1 is more labor productive than firm 2 in the sense that the average product of labor in firm 1 is higher than that in firm 2. But in terms of capital, firm 2 may be more productive than firm 1 because the average product of capital may be higher for firm 2 than for firm 1. Which firm is more productive depends on which factor of production we discuss, and whether the firm is labor-intensive or capital-intensive. Let's find answers to exercise 6.4. Firm 1 and Firm 2 use the same type of production function, but Firm 1 is only 90% as productive as Firm 2. That is, the production function of Firm 2 is Q2 equals FLX, and the production function of firm 1 is Q1 equals 0.9 times FLK. At a particular level of inputs, how does the marginal product of labor differ between these two firms? We can write down the marginal product of labor for firm 1 and for firm 2. We find that the marginal product of labor for firm 1 is 90% of that for firm 2 at a particular level of inputs. Let's solve exercise 6.5. Is a boss a fixed or variable input? In the application, a good boss raises productivity. How does having a good boss affect the marginal product of labor curve for this firm? Assuming that the production process also includes a capital input, what effect does a good boss have on a typical isoquant? In the short run, a boss can be seen as a fixed input. A good boss moves the isoquant in a way that for a given level of capital, K bar, less labor is required to produce the same amount of output, for example, 10 units. Let's jump to the challenge part of this chapter. Here's exercise 7.1. If a firm lays off workers during a recession, how will the firm's marginal product of labor change? It depends on the firm operates at which part of the marginal product of labor curve. If the firm initially operates at the part from point A to point C, then laying one worker off increases the marginal product of labor. If the firm initially operates at the part from the origin to point A, then reducing labor leads to a reduction in the marginal product of labor. Let's find answers to exercise 7.2. During recessions, American firms historically laid off a large proportion of their workers than Japanese firms did. Assuming that the production function was unchanged over many recessions and expansions, would you expect the average product of labor to have been higher in Japan or in the United States? Why? The average product of labor might be higher in the United States than in Japan because the average product of labor usually rises as firms lay off workers. This conclusion is based on the assumption that the firms in the two countries have the same production function and operate at the part of the marginal product of labor curve from point B to point C. Laying off workers results in an increase in the average product of labor in this range. If the firms have different production functions or different technologies, or they operate at other parts of the curve, then we cannot make such a conclusion. Let's solve the last exercise. For the CES production function, Does partial average product of labor over partial labor have an unambiguous sign? For the constant elasticity of substitution production function, we can write its average product of labor and its marginal product of labor functions. Then we take the derivative of the average product of labor with respect to labor. We find that it equals the difference between the marginal product of labor and the average product of labor divided by labor. The sign of it depends on the sign of that difference. In case 1, if the marginal product of labor is greater than the average product of labor, the average product of labor increases as labor increases. That is because one more additional worker is more productive than the existing workers. That additional worker pulls the average up. We can find the condition for this case. The ratio of the marginal product of labor to the average product of labor should be greater than 1 in this case. We can find the condition that if the parameter d is greater than an expression, then the average product of labor and labor move in the same direction. By contrast, if the marginal product of labor is smaller than the average product of labor, the average product of labor will decrease as labor increases. That is because one more extra worker is less productive than the existing workers, and he would push down the average. In this second case, the parameter d should be less than that expression. For example, if d equals 1 and a is the share between 0 and 1, then the average product of labor decreases as labor increases. Thank you very much for solving all the exercises in Chapter 6 with me. See you soon in the next chapter. Thank you for watching this video and subscribing to my YouTube channel. See you next time.